In this video, we will learn how can we use Excel to help us to calculate the confidence interval for the mean of y. In order to calculate the confidence interval for the mean of y, you need to know how to get the regression output. How should you get the descriptive statistics? If you have trouble to know how to get those two outputs from the Excel, you should watch the video related to the regression analysis and descriptive statistic. So if you know that, you can start to watch this video. So from the slides and the textbook, we know that if we want to calculate the confidence interval for the mean of y, you need to know certain formula. So the formula I've already helped you to list here is equal to the y hat plus minus the t statistics times sy. So the first question is, how can we get the value for y hat, and how can we get the value for sy? Once we know these two values, and we can plug in this formula to get the upper and the lower boundary for the confidence interval for the mean of y. So first, let's look at the question. So the question is, if 3 TV ads are run prior to a sale, we expect the mean number of the car sold to be what? And we want to calculate, given the 3 TV ads are run prior to the sale, what is the confidence interval for the mean of the number of the cars sold? So now the information we know from this question is the x equal to 3, because 3 TV ads are run prior to the sale. So what we will do first is we will get the value for y hat given the value of x. And in our regression analysis, and we already know how our estimated regression equation looks like. So the equation is y hat equal to b0 plus b1 times x. And in order to find the b0 and the b1, I mentioned in the previous video about how can you read the regression analysis result. And so you will find, let's go back to look at regression analysis result. So on the third table from the regression analysis result, you will have the intercept and the TV ads. So the coefficients corresponding to the intercept here, 10, is the value for B0. So we can come back here to write down the B0 is equal to 10. And the B1 is also in the third part of our regression output. The coefficient corresponding to the TV ads, we got 5, and the 5 is our B1. So we can write down 5. And as I mentioned in this example, the x given is equal to 3. So now we can get our estimated value for y hat, which we will use it to calculate our confidence interval. So the y hat equal to, so type in the equal, the Excel will help you to calculate y hat. So y hat equal to the b0, based on this equation, the b0 plus b1 times our x. Then we got 25, which means if a TV ads are run prior to the sale, we expect the mean of number of the sales sold to be 25. So we got the 25 for y hat, which is the first component for our confidence interval for the mean of y. So now we want to figure out another component as y star. So if you look at the textbook and slide, you will know the formula for you to calculate the confidence interval to calculate the sy star is equal to s standard error times the square root of 1 over n plus x value, so x here we got 3, minus the mean of x, and powered by 2 divided by the sum all of the xi minus x bar and powered by 2. And as I mentioned, this part actually equal to this formula, the s standard error times the square root of 1 over n plus x, the value we are given, minus the mean of x and powered by 2, divided by n is the number of the observation minus 1 times the sample variance of x. So now the question is, where can we find the value for the standard error? Where can we find the value for the number of the observation? Where can we find the x bar, the mean of x? And where we can find s x powered by 2, which is sample variance? And then once we know the 4 elements, and we can calculate what happened inside of the square root and the times s, and we will get our s y hat. So now let's find the standard error. So the s actually is our standard error, and the n is the number of observation, and the x bar is the mean of x, and s x powered by 2 is the sample variance of x. So now let's first find the standard error from the regression output. So if we go back to look at our regression output and the standard error, you will find one cell is named by the standard error. Yes, you should find it. So it's on the first table in our Excel output called standard error, 2.1602. So that is our value for S, 2.1602. 2.1062. Double check it. 2.1602. So this is our standard error S, which we will use in our equation here. So the number of the observation. So if you go back to the regression output, so here we have still in the first table we have observations. So we got 5. So 5 is our number of the observation, which is the value for n. So the x bar, the mean of x, and the sample variance of x. So where can you find these two statistics? The place you find these two statistics is from the descriptive statistics, not regression. So we know the TV ads is our x. Make sure you know which is x. So the TV ads is our x. So the mean, the average of the TV ads is 2. So here is x bar. And the sample variance, don't use the standard deviation, use the sample variance. And we got 1. Now we can go back to filling our blank. So the mean of x is 2, and the sample variance is 1. So now we know in x bar sample variance of x, then we can start to calculate what happened in the square root. So now typing equal SQRT stands for the square root, and the parentheses, and 1 over n, and the n we just know is 5. So that's a C20 cell, and a plus. So the x, and we just know it, the x equal to 3 is given by our question. So 3 minus the mean of x, x bar, close the parentheses powered by 2, and divide by the n minus 1. N is 5 minus 1, close the parentheses, and times the sample variance, which is 1, and close the parentheses, and close our SQRT. Then we got 0.670820393, so that's the value for the square root. So now we can get the SY hat by typing equal sign, the standard error, times our square root. Then we got 1.449106213. That is the value for SY hat star. So now we can combine different parts together to find our lower boundary and upper boundary for our confidence interval for the mean of y. So now before we do the calculation, the step 3, we need to know how can we get the t-statistics. As I mentioned, you can find it from based on a t-table, but here we are using the Excel, using the function called equal t-inverse, equal TINV. So that's a function we will use to get t-statistics, and parentheses. So the probability we use is since it's 95% confidence interval, we use 0.05 and common. So the degree freedom, so if you are not sure the degree freedom, you can go back to look at the regression analysis. So the degree freedom is always be the degree freedom for the residual. So that is 3. So 3 is the degree freedom in our models. So you can type in 3 and close the parentheses and push the enter button on the keyboard. So the t-stat is equal to 3.182446305, and the y hat we just calculated is equal to 1.4491. Now we can get the lower boundary. So the lower boundary is the y hat. Y hat we just get is 25 minus the t-statistic times the s hat. So the lower boundary equal to the 25 minus t-statistics times the sy hat. So we got 20.398831706. So the upper boundary. So the upper boundary equal to the y hat plus, because it's plus and minus, plus t-statistics times the sy hat. So the upper boundary is 29.611682994. So which means if you want to write down the confidence interval for the mean of y, you should write down the parentheses 20.3883 common. So that's the lower bound to 29.6117. That's the upper boundary, and close the parentheses. So this is our confidence interval for the mean of y. So it's from 20.3883 to 29.6117, and you will use similar idea to calculate the prediction interval. The only difference is here, instead of 1 divided by n plus this component, you need to add 1 plus 1 over n plus x star minus x bar powered by 2 divided by n minus 1 and the sample variance of x. Everything are the same except what happened in the square root. So you just add one more 1 into the square root.